So I have started recording the class and sharing my screen also. Let me know if you guys are able to see it. Yeah. Can you
Yeah,
see
we
it?
see. We see
Yeah.
it.
Can you see the whiteboard?
No, I can't see the whiteboard.
How about now? No?
No, no, no.
Okay, let me share it again. I think it stopped sharing all of a sudden. Okay.
Yeah,
Yeah.
now I can see it.
How about the
I can see
whiteboard?
the white screen. Yeah, I can see it.
Okay, wonderful. And same for you also, Anna, right?
I can
Anna,
see it.
okay, wonderful. So, yesterday we were learning about something called Pythagorean theorem. Theorem. So, Arnott, question to you: is it what is being taught to you also in the class right now? Or
Yes.
okay, wonderful. Then we are on the same page. So, Pythagorean theorem or Pythagoras theorem, whatever you call it, it relates to a right angle triangle. Okay, meaning one of the angle is 90-degree, and we know in the case of a right angle triangle, this is, if I'm calling this as base, this is called adjacent side, and this one we call as hypotenuse. Yeah, are you with me?
Yeah.
I was just drinking something.
Okay, that's okay. So let's call this side as C. Okay, so in this right angle triangle, this is my base and this is the adjacent side. So these two sides together make this angle 90-degree. And I'm calling this hypotenuse as C. So what Pythagorean theorem says is a square, which is this one, plus b square equals c square. Meaning square of the sides making 90-degree equals to the square of the hypotenuse. This is what we tried learning in the class yesterday. Okay. So Arna, what I would suggest is you go through that yesterday's classes video and let me know if you find anything which is not easy to understand. Okay.
Okay.
Yeah. But the Pythagorean theorem will not change regardless of whether you see the classes video or not. What it means is, again I'm repeating, Pythagorean theorem says, or Pythagorean theorem or Pythagoras theorem says that in a right angle triangle, the square of the sides making right angle, meaning side A and side B, which makes that right angle, square of the sides making the right angle is equal to square of the hypotenuse.
Okay.
Now, if I'm talking about this triangle, okay, this is right angle triangle. What are the sides making square? This side and this side. Okay, and what is the hypotenuse? That is the side which is opposite to the 90 degrees. This one. So this side's square plus this side's square equal to this hypotenuse square. And now you call it A, this is called, you call it B, and this you can call it X, up to you. But the formula is A square, meaning this side this side's square plus this side's square equal to this side's square, which is X square. Now if you are dealing with a triangle, right angle triangle, this is K, this is L, this is M. Pythagorean theorem says this the sides making the right angle, meaning this side and this side, meaning K square plus L square equal to M square. Okay.
Okay.
Why I'm explaining it this way? Because people tend to remember A square plus B square equal to C square, and they forget what is A, what is B, what is C. Yeah. So that's why I'm trying to make you guys remember the fact that as per the Pythagorean theorem, the sides that make the right angle, that is making that 90-degree angle, square of those sides equal to the square of the hypotenuse, meaning the side opposite to the right angle. That's the formula. Now it's
Ag-
ABC, KLM, XYZ, doesn't matter. Yeah, yeah, no, go ahead.
no, I was just saying okay.
Yeah. All right. Are
Yeah.
you with me, Mitran?
Yeah,
Yeah.
can I throw my drink away? Can I put my drink away?
Yeah, sure. So any doubt with this one, Arna, so far?
No,
No.
no.
Okay. There's one thing that I would want to teach you while Mitran. I mean, you'll see this in the video of yesterday's class, but quickly here. Okay. Do you know what is meant by two similar triangles?
What?
Similar triangles. Do you know what is similar triangles?
Back.
Equilateral?
Okay. Yeah. No, so Mithun, I'm just doing a quick recap of what we learned yesterday so that we can try deriving the Pythagorean theorem today.
Yeah, okay.
So, what is a similar triangle? That's what I'm asking Arna because she was not in the class yesterday. So, similar triangle means the triangles where the angles are equal to each other. Meaning, let's say if I have a triangle this one and triangle this one.
That's my elbows.
Yeah. So when you say the two triangles are similar, what does it mean is one of the angle in this triangle is equal to other angle in this triangle. Second angle in this triangle is equal to another angle in this triangle. And third angle will be similar to the third angle in the triangle.
Okay.
Yeah. So so for us to kind of remember this, two triangles are similar to each other if they have same value for three angles in the triangle. Okay. If this is one angle, this is other. This is one triangle. This is another triangle. What that means is if this angle is, let's say, 60-degree, meaning there'll be one of the angles which is 60-degree here. Let's say the second angle is 40-degree. That means there'll be one angle here out of the three in the second triangle which is 40-degree. Okay.
Okay.
What will be the third angle here in the first triangle? If I have one is 60, one is 40, it's a question to both of you. I'm just trying to see if you remember what we learned before. In a triangle, one angle is 60, another angle is 40. What will be the third angle?
The
Value of the
third
third.
the third angle will be 80 degrees.
Yes, because all the three angles put together is 180. So one angle is 40, another is 60. That means the third one is 60 plus 40, 100. And that is to be subtracted from 180. That is how it is 80 degrees. Now,
Mhm.
why I asked that question? The reason was if my two angles are matching, meaning 40 and 60, here also there's 140, 160. Third angle will match by default because any triangle and every triangle, the sum of all the angles will always be 180. So if you are comparing two triangles and you got two angles already matching, that means third angle has to match by default. You
Okay.
don't have to do that verification at all. Okay?
Mhm.
Are you guys with me?
Yeah.
Arna, are you with me?
Yeah, I'm with you. I'm just writing down notes.
Okay. No, I mean, I'm just trying to make sure that whatever I'm explaining is that something that is getting registered in your brain. Notebook you can lose, brain you will not. Okay.
Yeah.
Okay.
So I'm just repeating again. So any and every triangle that we'll see from now for rest of our life, the sum of all the angles will be 180 only. There will never ever be any triangle that will come across whose sum of angles will be anything different from 180. Now, What we are trying to learn is what is similar. What do we mean by similar triangles? Meaning two triangles where the angles are matching. Meaning one angle in a triangle has same value in another triangle. Second angle in the triangle has a matching value angle in the second triangle. If two angles have already matched, third angle will match by default because A plus B plus C is 180. A and B I already know. Okay.
Okay.
So third is 180 minus A plus B, and that will not change. Yeah.
Mm.
Now, Arna will ask me, why are we even talking about similar triangles? Similar triangle means triangles, two triangles who have same angles, but they're not same, they don't have same length of the side actually. So I can have, let's say, one equilateral triangle, all angles 60 degree, okay, with 4 centimeter side, okay, 4 centimeter side, and all angles are 60 degree, okay. I can have another equilateral triangle, all 60 degree angle, okay, all 2 centimeter side, okay. I can have another equilateral triangle with 8 centimeter as the side, as each side, okay, and the angle is 60 degree, okay. So here, if you look at this triangle, and this triangle, what is common among them? All the angles are 60 degree. So each each of the triangle have matching angle, but the sides are of different length. That is why they are called similar. Am I making sense?
Yeah.
Mitran, are you with me? And I will not move on.
He left.
He left. Yeah, seems some problem with the network. Okay. Okay. But you understood this, right, Anna?
Yeah, I
Oh,
understood.
okay. So similar triangle is something, it tells you that the shapes are matching because the angle between the lines are matching, but they are bigger or smaller in size. That's what it means. Okay.
Okay.
So they will look like triangles from the similar family.
Sorry, I sorry I left, but there was something wrong with my screen, so I had to close it down and reopen it several times.
That's okay. That's fine. You have not missed anything because you're already ahead. Because we discussed something yesterday which are now could not.
Okay.
Uh, so that's why you're not going to miss anything today for sure. Okay.
Mm.
So what I was telling as a conclusion to Arna was that when we talk about similar triangles, okay, similar triangles mean obviously the angles, they have matching angles, right?
Mhm.
But they could vary in size, so they will look like triangles from the same family, okay, similar inclination among them, but bigger, smaller in size. That's why they are called similar triangles. If you look at the three triangles that you are seeing on the screen right now, they look to have some similar properties, but different in sizes. Yeah,
Mm.
do you
Yeah.
agree?
Yeah.
So that is the purpose of this one. So it says, okay, if let's say like you guys zoom things, okay, let's say this one. Let's look at this example. Okay, I'm zooming it in. Come on. See what you're saying here. Same triangle getting expanded, but the angle between the lines, that is not changing, isn't it?
Yeah.
So that is what is similar triangle. When you say similar triangle, you're essentially talking about what happens. 100%. Right. Okay. Where did the triangle go? Oops. Okay. So what I was saying was, so similar triangle is something similar to the concept of zoom. Okay.
Mm.
So if I zoom in, so the angle between the lines, that is not changing, right? What is changing is only the size. That is what similar triangle means. Because there'll be two triangles. One is a zoomed in version, one is a zoomed out version. They look similar, but in different sizes. Okay, meaning the
Okay.
angles between the sides is the same, just that they are different sizes. Okay, all right. No doubt about the similar triangle, right? We played with similar triangle enough, isn't it?
Yeah.
Okay, all right. So see, I tell you guys to play with maths, right? That's what I essentially do. So I just now, while I was teaching you guys, I got that idea of zooming in, zooming out. That is how you can relate. Okay, because if you don't find the relevance of what you learned with what you do, you will tend to get bored and you'll end up forgetting it. Okay, fine.
Yeah, I understand.
Yeah, okay, okay.
Oh yeah, he left again.
Yeah, he is not. He knows that he has learned something yesterday. So, but he'll come back. I think there's some network problem, and that network problem will kill by being in person. Just that I had to travel, so that's why this problem. Okay, all right. So let's go to the next thing. So now, when we talk about similar triangles, okay, just look at it carefully. There's an interesting formula that I'm going to tell you guys. Okay, let's say these two are similar triangles. Okay, okay, A, B, and C. This is D, E, and F. Okay. If I say these two triangles are similar triangles, meaning all the three angles have a matching value in the other triangle. Okay, let's say this one. This angle and this angle matches. Okay, okay, and this angle and this angle matches. Okay, so these two triangles ABC and DEF are similar triangles. Let's say, okay, that and between the two triangles, where is Mitran? Okay,
Um,
okay. No, so you have not missed anything again. I'm just doing that ratio thing for Arna. Okay,
my screen just got blacked out, so I tried to like close it and reopen it to get the screen back on.
that's okay. This problem is only for today's class. Next week, anyways, we are going to be in person, so that's
Mhm.
fine. So here, what I was explaining Arna was that when you're dealing with two similar triangles, okay, let's say the ABC and DEF are two similar triangles, where obviously this angle is matching with this angle is matching with this angle, and this angle is matching with this angle. Okay, that is why these two are similar triangles. So what property of similar triangles says is, let's say this angle and this angle are same. Okay, meaning the sides opposite to um, the ratio of the corresponding sides will be same. What does it mean? Meaning, if this angle and this angle are same, what is the opposite side? This and this, right? This angle's opposite side is this one. 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 Yeah.
Mm,
Similarly, this angle's opposite side is this one. So here, what it says is the if there are similar triangles, the
mhm,
opposite sides will be in the same ratio. So now let's play with it.
mm,
I will make you guys play with maths. That's my objective. Now we are playing with it. So this angle and this angle are same in the similar triangle. What does it mean? Opposite side to this is what? BC. Let's say BC, and opposite side to this angle, which is same as this angle, is this is the angle. Opposite side is EF. So BC by EF. The ratio of this will be similar to the ratio of other corresponding sides. Meaning this angle matched. We took the opposite side of that. Now let's say this angle and this angle also matched. If they are similar triangles, then the opposite sides will be opposite to this one will be AC,
mm.
and this angle is matching here. So this opposite side is DF. and this will be equal to the third angle's opposite side. I'll come back to this, okay? Even if it is confusing, I will take care of it, don't worry. Now this angle and this angle are matching. That's why it makes these two triangles similar. So opposite side to this angle is AB,
Okay.
and opposite side to this angle is DE.
Hmm.
So this is what the property of similar triangles says. Meaning, if the two triangles are similar, then the sides opposite to the matching angles will be in the same ratio. Now, these two triangles are similar, ABC and DEF. That's what we have figured out, or that's what we have been told. And hence it says that the angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. This is why they are told that this is similar. So then, based on the property of similar triangle, what it says is the sides opposite to the matching angle are in the same proportion. Meaning, side opposite to angle A is BC, and side opposite to the matching angle D is EF. This will
Mhm.
be the same proportion as, let's take the next angle, the angle B and angle E. These two are matching. So angle side opposite to angle B is AC divided by side opposite to angle E is DF. And the third matching angle is C and F. So side opposite to angle C is AB divided by DE. Now I know it looks complicated. It looks bothering. It looks cryptic, but actually it's not. Why? Take a step back. First question to myself I will ask is why are two triangles similar? Because they have matching angles. Okay. So what do I do with the matching angles? What matching angles means is you will always look at the side opposite to the matching angles and they'll be in the same proportion. So if there are two triangles, let's say I will change the name of the triangles KLM and XYZ. These are
Okay.
two similar triangles, meaning angle K and angle X are matching, angle L and angle Y are matching, angle M and angle Z are matching. So basically, they have common angles, they have matching angles. That's why they are similar. So, as per this formula, I will just look at the sides opposite to the angle and they'll be in the same ratio. I'll first take the first angle, K. What is the side opposite to that? LM. LM is the side. Yeah.
Mm-hmm.
Which angle is matching to this angle in the other similar triangle? X. What is the opposite side of X? YZ. So, LM by YZ will be equal to, let's take the other angle. Take L. And what is the matching value for that one? That is Y. L, angle N and angle Y are matching. Okay. What are the sides opposite to that? Opposite to this is KM. And opposite to Y is XZ. Now let's look at the third angle. M. What is the matching value for this? Is Z. So what is the opposite side to M in this triangle? KL divided by what is the matching angle? Z. What is the opposite side? XY. Done. This is what it is. So, in simple terms, take two triangles which are similar. If there are two triangles which are similar, I will get the ratio of the sides for the matching angles, meaning the sides opposite to the angles, and they will match. This is the formula. This is a proven thing. Like we learned that sum of all the angles in a triangle is 180 degree. That's a universal truth. Same way, here also it says that if there are two triangles which are similar, the sides opposite to the matching angle will be in the same proportion. That's what it is. So this is the property. This one you don't have to prove. This is for you to know. And we will use this value, this understanding to prove how the Pythagorean theorem works. Okay. I'm stopping it here now. Let me see what is the expression of my kids.
Um, Miranda, sorry to interrupt, but I have to leave. I have another class to join.
That's okay. You can leave. I will probably spend 15 minutes with Darna, and then just kind of try catching her up on what we have learned yesterday, and then we'll try proving the Pythagorean theorem in the next class. Okay.
Okay, bye.
Bye bye. Take care. All right. So Arna, now a question to you. Let me stop recording, and I want to hear you.